Hello everybody, welcome back. So now let's solve the second problem, problem 2. This problem requires a little bit of iteration, but it's okay. I'll walk you step by step through it. So what is given in the problem is say a spear is falling down steadily. Very important later, okay? Because steadily mean that A equals 0. Okay, this is a solid spear. Wonderful. So our mass is rho times V. So what do we have? They given the spear density to be 800 kilogram per meter cube. Fluid density, or I would say density of polymer to be 1,500 kilogram per meter cube, and you have mu is the viscosity to be 0.3 Pascal per second, or Pascal second is also same as kilogram per meter times second. Okay, ut, terminal velocity, is 3 meter per second. Okay, and I will use 9.81 meter per second square for the gravitational constant. What is the question? They ask for diameter D. Diameter D. Okay, so how do we start this problem? We draw the spear. So let's go ahead and draw the spear out. Okay, you have a very nice spear right there. It's going down, so the velocity is gonna go like this. And remember, this is negative, this is positive, because our axis is gonna based on the direction of the velocity. The spear is falling down, which means the thrust force is gonna going up, Fd. And then you have your buoyancy is only go up, and your gravity always go down. Okay, let's do it with me. Okay, using Newton second law, summation of force equal to ma. So what you get Fg minus Fb minus Fd equal to m times du over dt, which is 0. Okay, because it's steady state. Velocity doesn't change to time. Okay, what is Fg? Fg is rho s times v times g minus what's Fb? Fb is the buoyancy, so it's because of the fluid. So you have rho f times v times g. Okay, what is Fd? Fd is 1/2 AP times rho f times ut squared times drag coefficient equals 0. Okay, all this equals 0. Okay, and what is our what's that volume again? Our volume is always pi d cubed over 6. Okay, it's always like that for a spear. You can rewatch the first video if you want for clarification. You plug this v into here, so you read rho s times pi d cubed over 6 times g minus rho f times pi d cubed over 6 times g minus 1/2 AP rho f times ut squared times cd equals 0. Okay, you do some arrangement. Remember, what are we solving for? We are solving for the diameter d. Right, so d, you do some algebraic rearrangement, you arrive at equal to 3/4 times rho f times ut squared times drag coefficient times g over solid density, spear density with rho s minus rho f. Wonderful. In your mind, you might be thinking, oh man, just go ahead and plug in all these numbers. I get it. I immediately I sincerely I want my life, your life to be that beautiful too. I sincerely want you to go hiking and go biking and unfortunately um this is the chemical engineering degree and we of course there's gonna be some altercation and let's see what is that. So the thing is with this equation, give me 1 second. Okay, I see. The thing is with this equation, you need to rearrange a lot. Let me see which equation to use. Okay. So this equation is theoretically it because the bad news is we not given UT. That's the thing. Okay, let me write issue. UT is not given. Okay. Okay. Now. Okay. So this is the this is the way to go. I'll show you. Okay, don't be despair. Bear with me. So first, you start with CD. This is you need to create what? You need to create an Excel sheet. Okay. First, you start with initial guess for track coefficient. You can play with this value. You can play with this value anywhere from 0 to 1. I would say typically 0.5, typically 0.5. In this problem, I pick track coefficient to be 0.3938. Okay, now this is how you're gonna start. You start you start with the initial guess. Need to create an iteration table. Okay, now so what you're gonna do is you have your initial guess already, right? Initial guess CD. You're gonna use equation. You're gonna use this equation. Okay. You're gonna use Reynolds number. I need to find where it is for y'all, but basically this is where to start. Okay, so from CD to RE, from track coefficient to Reynolds number, you're gonna use this Reynolds number equal to 3 times CD times rho F squared times UT cube over forward times mu times rho S minus rho F times G. Okay, you're gonna get Reynolds number. Okay, now later you will from this you're gonna solve for diameters. Okay, how will you do that? You say diameters equal to Reynolds number times viscosity time over rho F times UT. Okay, So from Reynolds number to CD, you're gonna use equation 4.11 on page 196. Okay. And then you repeat the loop. Okay, let me write better for y'all. You're gonna repeat the loop. So you're gonna find Reynolds number again using this equation. Let me highlight this. Using this equation, the yellow equation. Then Reynolds number. From Reynolds number, you're gonna solve for diameters using this blue equation. And then Reynolds number, you're gonna solve for track coefficient again. Yeah, you see the deal. Okay, you're gonna keep doing this. Okay, using, let me using the purple equation. Okay, let me clarify. You start with the initial guess track coefficient. You find the Reynolds number using the yellow equation. You find the diameters using the blue equation. From that Reynolds number, you can find the track coefficient again using the blue equation 4.11 page 196. You keep repeating that until D converge. To diameters converge. You stop. Okay. So after 20 iteration, you arrive at diameters equal to 0.0621 meters, Reynolds number equal to 776.41, track coefficient equal to 0.48746. Okay, so our diameters would be 0.0621 meters, or in other words 6.21 centimeters. Okay, that is our final answer. Okay, thank you everyone for your attention, and I wish you an amazing night. Thank you.